So in this course, I will be using the Repl from Atom Text Editor, and in this short tutorial, I want to show you how I do Repl-driven development in Atom. So if you go to your settings on Atom Text Editor and go to Packages, so the package that we are going to use is called Chlorine. As you can see, I have already installed on my machine. If you haven't done so, please go ahead and do that. This is the first step. Once you have installed Chlorine, I want to show you some of the key bindings that I use to to start Chlorine. So if you scroll down, you'll see the key binding section, and these are some of the ones that are built in, that comes with Chlorine itself, and you can modify it. So what we want to do is, I like using my own configuration. It just makes it easier for me, because when I'm using on a different text editor, I try to follow this consistency. Okay, so the next thing that we are going to configure is the key bindings. Well, Chlorine already comes with the default key bindings, as you can see over here. What we want to do is set up our own key bindings. Now let's look at some of the key bindings that we will be using. The first one is Chlorine Connect Socket Repl. So this will connect our IDE to a running socket Repl, which we will see very soon. So right now here it says Control and Y. There's also one that says Chlorine Disconnect. This will disconnect you from the server. There's also, okay, so since we are using Shadow CLJS in this application, let's go ahead and see how it works with the Shadow CLJS. So over here it says, with Shadow CLJS, after watching, you connect with Clojure Connect Socket Repl, which we earlier saw how to do that, right? And then you run the command connect embedded. Cool. So you need to run two commands. First, you need to connect to the socket Repl, and then you need to connect to the build itself. So in our case, it'll be the app. So let's go ahead and configure these two commands. So if you go to key bindings and click on your key map file, you will find, so over here it says key bindings. You can override these key bindings by copying and pasting them into your key map file. As you can see, your key map file is highlighted in blue, means that it is a link to that key map file. A link to that key map file. So what we are going to do is we are going to go there next. Let's click on your key map file, and here you go. Let's pause on this page for a second, and let me just go through some of the most important ones. So in the keymap.cson file, so I have my own custom key maps over here. So the ones that we are interested in this tutorial is the Chlorine Connect Socket Repl and Chlorine Connect Embedded. So in order to connect to your socket Repl, it's Option Command and Y. And once you have done that, next you need to connect to your build itself, so Connect Embedded. So before you do that, you need to make sure that your browser has rendered that web page. Otherwise it won't work. So once your browser has rendered the page, and once you have connected to the socket Repl, you can finally connect to the build, and that is done by Option Command and Option Command and U. So let's go ahead and do that. Let's connect to the Repl next. There are three more commands that I would like to go through. The first one is disconnecting. That is Command, Option, and I. So that will disconnect you from the Repl. There's also one Option Command and K that will clear the console. So if you have a lot of Repl prints and if you want to clear out everything, and that is the key map for you. And there's also the clear inline results. This will clear out all the inline results that is in your IDE from the Repl operation. So so as you can see, it becomes very easy, right? Alt or Option and Command are the keys that you are pressing all the time, and depending on the letters. So if you press Y, it means it connects to socket Repl. U, it connects embedded. So it's just, for me, it's easier to work like this. I don't know. If you like the default version, you can always use that, right? So, but I just wanted to share how I use the Chlorine. But anyways, let's go ahead and connect to our socket Repl next. So the first thing that we need to do is let's go ahead and connect to our socket Repl. So as you can see, the N Repl is running in 3333, but as you can see, so let's go ahead and connect to our socket Repl. Okay, as you can see, we have connected to our Shadow CLJS build target app, right? And now we can execute pieces of code from the Repl, from the text ID itself, and it's really cool thing because it allows us to, again, try new things, try new code bases, try new functions, whatever. So that is done. Let's try out some functions, JavaScript functions. Let's try alert hello from CLJS world, and if you execute this piece of code, you will see an alert on your web browser. There you go, it works. Let's delete that and let's try console logging conduit. Okay, let's run, and if you open your console, there you go. Okay, so next, so far so good. We have a basic reagent application set up. We also have we have installed Chlorine, we have connected our Repl. Let's go ahead and commit all these changes to Git. Okay. Next, what we will do is we will go to the first branch of the React Redux example app, and we will see what is in the branch number 1. Okay, so it looks like we have made some changes on the JavaScript code. We have to stash all this because we don't really care. I just wanted to show you an example of how you can create a functional component, but yeah. Okay, so let's stash the changes and let's change the directory to 01. So let's see what are the directories that they have. So let's check out all the branches. So as you can see, this repository has from branch 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 10. So we will be going to branch 0.1. We will be going to branch 1. Enter. Cool. Okay, so what's wrong? Status. Wait, what? Okay, so let's check out branch 0.0. Okay, because we were in the master branch, okay, so now it looks good. So on the first branch, it looks like it's a tutorial for Redux, so we will skip the first branch and we'll check out the 02 because we don't really care about Redux. We're not here to learn Redux. Okay, there you go. So on the second branch, we see few changes, well, quite a lot of changes. Now we have a header, we also have a banner that says conduit, and there's like message that says place to share your knowledge. Okay, and then underneath that you have two more components. The one on the left has a tab called global feed, and you have a text that says loading. And on your right you have a sidebar that displays tags, but obviously right now there's nothing to be rendered. Okay, actually, you know what, let's go and open Firefox. I think Firefox has better developer tools. So let's go and change. The reason why I use Chrome is because at work you need, our software. Anyways, let's go and use Firefox. Okay, so let's open the developer toolbar and inspect how it looks like. So if we go ahead and look at the inspector, we can see we have a div with an ID of root, and it has a single child of div, and this div has two child components. The first one is nav. That nav is the component that renders conduit on the top left, and it has a couple of classes, navbar and navbar light, and below that we have a div called homepage. Let's go back to the terminal and we will create a new branch called 02. Again, we are skipping 01 because the one branch on React is about the tutorial on Redux, so we don't really care about Redux again. So that's why we are checking out to 0. We are checking to 02. We're checking out the branch to 02. Okay. Okay, cool. So let's open our ClojureScript code on an Atom text editor. And let's quickly go through this file. So this is a normal React and Redux application. As you can see, we have a default state, and this state has two key value pairs. The first one is the app name of conduit and articles of null, and then there's the reducer. A reducer is the function that changes the state. For now it's just returning state, and also we are using the create store function from Redux to create the store itself, and the store is required by provider on line 17, and provider has a single component called app, and this app has pretty much the business logic, which we will see next. So let's go to app.js. So app.js is basically a class-based component, and it has one method, which is the render, and every component should have at least one method, the render method. And so this render returns a div, and this div has two child components, the header and home. And this is the idea in React. Composition is a very important characteristic. As you can see, this is an example of composition. App composes the header and the home component, right? And they are actually coming from different folders. So as you can see over here, header is coming from the header file and home is coming from home file. So this way, the one really great thing about React is that you can really write components that just does one thing, so that adheres and that follows the single responsibility principle. So yeah, the idea of composition, but yeah, so if you can guess what the header does, I'm pretty sure this header is this component over here. And okay, so let's go ahead and see what the header component looks like. So the header component is a nav, which has the class of navbar and navbar light, and inside a div with a and it renders the app name. So this top part over here, that is the header. So if this is the header, means the conduit and the global feed stuff is in the home page. So if we go to the home page, okay, so before we go ahead and see the home component, let's go ahead and write our first component, the header component. And inside app, we will delete everything that we have, and we will create a component called header. It looks like we have capitalized C. Let's change it to small c. And perfect, you have written your first header component. Next, let's go ahead and see how the home component is being implemented. So if you go to source components, you'll see a folder called home, and inside this home directory, go to that index.js file. So as you can see over here, home component imports 4 things: the banner component, the main view component, and the React itself. It also imports connect from React Redux. So the home component is a class-based component, and again, it has a render function. This function has a div of class homepage. So the home page has a div of homepage, and then next we have a component called banner. This banner takes a single property, a prop, the app name, the conduit, and below that we have a div with a class name of container and page, and it has a single child with the class name of row. And inside this div we have 2 components: the main view component, which we haven't seen yet, and the popular tags component. And as you can see, the popular tags has a div with a class of called md3. So let's go ahead and implement this in our ClojureScript code. So we will create a new component called home page. So as you can see, we have a single div with a class name of homepage, and on top we have the banner, and on the bottom we have the popular tags. And for the main view, let's just say main view for now. Let's go ahead and implement the banner component. Okay, so first let's create a div and give this a class name of banner. We will use the short form to give it a class rather than giving it a map and writing it a class. It's just easier and it becomes more concise. And if you look at the banner component, the banner and container, banner has a single child, and container, because the fact that banner has a single child, you can nest the 2 divs. It should be when the token does not exist, then they should show. So there's clearly a typo. By the time I finished recording, I didn't realize it, but it should be when not token. And as you can see, this has a div with a class of banner, and then you have another div with container and h1 and p. And just see how concise the ClojureScript code is compared to JavaScript code. Now, if you're looking at the JavaScript code, look at the amount of syntax that this code has. You have const, you have banner, you have, okay, so this is not that bad, but you have this equal sign, you have this parentheses, this curly brackets, commas, this arrows, curly braces again. Then you have this return, you have if, you have combination of all this. And look at the way how, if you just look at the way how, if you compare the two components between the React and ClojureScript, ClojureScript component, banner component is implemented in 5 lines of code, while the banner in JavaScript has taken almost 15 lines of code. And this is important because it, you know, the less code that you have, the less line of code that you need to worry about, the less bugs there will be in the application, the less codes that you need to test. So this is a huge win for ClojureScript. Next, what we need to do is implement the okay. Let's go ahead and close this. Okay. And let's go back to the home page. And now we need to implement the main view. Let's go ahead and click on this component to see what is inside. So the main view is again a functional component, and this component has a div with a class of call mid9, and inside this div has it has 2 child elements: the article list component that takes the articles from the props, as well as the some div with the UL, and you have, and so let's go ahead and implement the main view. This main view has a div with the class call-md-9. Inside this div is 2 child elements, right? The div with the class of feed toggle and the articles list itself. So we'll have to create another component called articles. This article component takes a single argument called items, and let's define this article component now. So article list in JavaScript is a functional component, and it accepts a single argument called articles. And if the articles does not exist, then it means that it is in the process of fetching that articles from the networks. So we show a div with a class of article preview, and we show loading. Next, if the article's length is 0, means that there is no article here yet, right? So there's nothing. And if once we have the article, then we map over each article and show it in an h1. And once we do have the articles, then we map over the article and we show it in an h2 tag, the title of the article. So let's go ahead and implement the article list component in ClojureScript. So we will name our component articles, and it accepts items. So, okay, so we will say if the items does not exist, so that's what if not seek items does. So if the items is truthy, so if it's not an empty vector and if there's actually articles, it will run truthy, which means it will go to the next. So here we say if there's no items, then we will show loading, and else if else we count the items, and if it is equal to 0, means that there's no articles here, and finally we show the articles. Before we go ahead and do that, let's go back to our the main view and fill out the rest of the stuff. Next, let's try to add some mock data. For now, we will add a single article called "Backpacking is fun," and let's just see what it looks like. Again, so everything looks good. We have implemented our articles component. Now the next, again, let's compare the JavaScript implementation of articles list versus the ClojureScript. Here again, as you can see, the articles components is only 7 lines of code, while the JavaScript implementation is, again, it's long. So as you can see, the benefits that ClojureScript functions provide, most of the functions in ClojureScript are small, they are tiny, and when you have smaller functions, it's easier to manage.